In this video, we are going to discuss about partial differential equations. First, we define what is partial differential equation. So the definition, any equation contains partial derivatives. Any equation. Here I have written an equation contains partial derivatives. So in general, any equation contains partial derivatives is called partial differential equation. So for example, dou square u by dou x square plus dou square u by dou y square equal to sine x plus y. I hope that you know the difference between the partial derivative and ordinary derivative. Okay, anyhow, I will tell one more time. There is no issue. If any function y depends on only one independent variable, see here, this function y depends on only one independent variable. So while differentiating this y, what we do, we write dy by dx is equal to f dash of x. So what is the meaning when we use d? It states that the function or the dependent variable depends on only one independent variable. For instance, let us come to the partial derivatives. When z is a function depends on two independent variable. For example, see here, this z depends on x, this is the first independent variable, and y, the second independent variable. So whenever you want to differentiate this function z, then you have to use the notation dou. So we write dou z by dou x. So when you see this dou, it means this z depends on two or more independent variables. So we say dou z by dou x equal to f dash of x comma y. Dou z by dou y. So don't forget, whenever we use dou, it means the function depends on two or more independent variables. So it is f dash of x comma y. Okay. So in this video, what we are going to discuss in detail. Okay, just I am going to discuss four topics. The first one is, let me write in a different color. The first one is order and degree of PDE. In short, we say PDE, partial differential equation. The order and the degree of the PDE. The second one, the formation of PDE by eliminating arbitrary constants. The third one, the third one is similar to the second one. Here also we discuss about formation of PDE by eliminating arbitrary functions. See the difference, arbitrary constant and arbitrary functions. And the fourth topic is the classification of second order PDEs. The classification of second order PDEs. Okay, so we will go one by one. The first one, the order and the degree of PDE. order and degree of the PDE. So this is the first topic. Okay, so we can go on. I give some set of questions. From there we can find the order and degree directly. See here, find the order and degree of the below PDEs. Below PDEs. The first one, dou z by dou x, dou z by dou y equal to z plus xyz. So the second one, let me take something from the book. It's better. Okay, let me give directly from my mind. So dou square z plus dou x square plus 4 dou square z by dou y square equal to 4z. The third, dou square z by dou x square whole power 3 is equal to dou square z by dou y square. The fourth one, dou square z by dou x square is equal to 1 plus dou z by dou y whole power half. Okay, let us see the questions. Let us see these questions one by one. See the first question. Okay, you know how we define the order. Okay, so in the differential equation, take the highest order derivative. Okay, for example, if you see the first one, we have first order derivatives. We have first order partial derivatives in particular. Okay, and even see here, this is a first order, this is first order, and here also first order. Okay, so what is the order? So the order is equal to 1. Okay, how to find the degree? How to find the degree? So what is the degree? You can say it is the power of the highest derivative. The power of the highest derivative. Here both are first order. So just to see the power. What is the power for this derivative? So what is the power? Nothing is there. So you can say the degree is equal to 1. Okay. So don't forget, when you take the degree, you have to go to the highest order derivative. From there you have to pick the degree. Okay. So not from anywhere you like. So let us go to the second question. So see the second question. Even in the second question, if you see, we have two partial order derivatives, even both partial order of a second order. So here also second order, here also second order. So what is the order? What is the highest order? Highest order. So the order is equal to 2. Here also you have to check the degree because both are second order and you have to take the power from the second order. Okay, so what is the degree here? The degree is equal to 1 because see the power here, it is 1 here also it is 1. So whenever you want to find the degree, you can see in the simple way the highest power of the highest derivative. We can say the highest power, because if one place we have one, in another place we have two, you have to take the highest power of the highest derivative. Don't forget. Okay, let us come to the third question. So what is the order here? Even here it is second order, even here it is the second order. So what is the order? The order is equal to 2. What is the degree? What is the degree? See here, in this side we have 1, and in this side we have 3. But what is the definition? Even I write the definition in this side. So what is the degree in the partial differential equation? So if you want to find the degree, it is defined in this way. The highest power of the highest derivative, the highest power of the highest power of the highest derivative, highest derivative. So what is the degree here? The degree is equal to 3. Degree is equal to 3. So let us come to the last one. So what is the order here? Order is equal to, what is the order? See here we have the first order, whereas here we have the second order. So what is the highest order? It is 2. Okay, so it is not 1. So there are two derivatives. The one is first order, the another one is second order. Don't forget, when you take the order, you have to take the highest order. Okay, so the order here is 2. But if you want to find the degree, don't forget, whenever you want to find the degree, first remove the radicals. Okay, just to see here, this is a radical. Radical means something like a square root with some square root. Okay, because power half is same as square root. So first you have to remove the radical. So how to remove the radical? So what you can do, first square both sides. See, the order is very clear. Okay, just by seeing the highest order of derivative, you can write the order. But if you want to write the degree, you have to be very careful. First check whether there is a radical or not. So if there is such a radical, first you have to remove it first. So what I do, I take to the power of 2 on both sides. Why? What is the purpose? Just to cancel these two. If I cancel the 2, automatically the radical is gone. So now check the degree. So what is the degree now? It is 2. Okay, so don't forget, in this question, what I try to insist, whenever you want to write the degree, you have to be very careful. So first check any is there any fractional power. If there is any fractional power, first you have to remove it. Okay, once you remove, okay, so even sometime we may have negative powers also, even that power should be removed. So once you remove the negative powers as well as the fractional powers, then you have to find the degree. Okay, so this is the way to find the order and degree. Now let us go to the formation of PDE. So the formation of PDE is done in two ways: by eliminating the arbitrary constant and by eliminating the arbitrary function. So let us enter the second topic, the formation of PDE by eliminating arbitrary constants. Eliminating arbitrary constants. So for this, just let me take some questions from the book. So that's the best thing. Okay, so see the question. Question number 1. Let me put in a different color. Where is it? Another color. So see question number 1. Form the PDE by eliminating arbitrary constants A and B from the equation. What is the equation? 2z is equal to x square by a square plus y square by b square. Okay, so you know the old stories when we formed the ordinary differential equation. So first you have to count the number of arbitrary constants. So first after finding the number of arbitrary constants, you have to differentiate those many times. But here, don't forget, you have to keep the number of independent variables in your mind. Here the function z depends on two independent variable x and y. So keep that in your mind and based on that find the derivatives. Okay. So see here how I am doing. So let me change the color. So answer. So differentiate. You can write in this way, but it's up to you. Differentiate partially with respect to x and y. First, I am going to find the derivatives, partial derivatives with respect to x and y. So now see here, I take the function 2z is equal to, I rewrite 1 by a square x square plus 1 by b square y square. Just I rewrite the given function in the different way. So I'm going to differentiate with respect to x first. So with respect to x. So I write w or tx with respect to x. So what will happen with respect to x? Okay. So 2 dou z by dou x is equal to 1 by a square. The derivative of x square with respect to x is 2x. Then plus, if you see in this place, you don't see any x. Okay. So do you see any x here? Do you see any x here? So no x. So what is the partial derivative? So as there is no x, automatically it will become 0. Okay. So from here, just try to simplify further. What do you get now? So here you can cancel 2 on both sides and you can bring the x to other side. So what will happen? It will become 1 by x dou z by dou x is equal to 1 by a square. Don't forget, we have to eliminate, we have to remove the arbitrary constants. It is better to find equivalent value for those arbitrary constants. Okay, so that is what I have done. So in the place of 1 by a, just to see here, in this place, in the place of 1 by a square, I can replace this value. That is the purpose. So that's why I have found the value of this arbitrary constant 1 by a square. Okay, in the same manner, I am going to differentiate with respect to y. With respect to y. So what will happen? So this is equal to 2 dou z by dou y is equal to, if you see this place, here you don't see any y. So it means automatically when you differentiate, that will become 0. Then plus 1 by b square. The partial derivative of y square with respect to y will become 2y. Like the previous step, here I can cancel 2 on both sides and I can bring this y to other side. So what will happen? This will become 1 by y dou z by dou y is equal to 1 by b square. Okay, so that's all. The task is done. And what I do now, I take this equation, I take this equation. Now I have two equivalents for the arbitrary constants. Okay, so it is 2z equal to 1 by a square x square, then plus 1 by, just I rewrite the same equation, 1 by b square y square. So it is 2z is equal to 1 by a square. So what is 1 by a square? You can put this value. So it is 1 by x, dou z by dou x, then multiply x square. 1 by b square. What is 1 by b square? It is written here. So 1 by b square is 1 by y, dou z by dou y. Then in here in this place we have y square. So I just copy it. So here in this place, in this step, I think we can cancel 1x, 1x as well as 1y. And I am going to write the remaining x in the front, the remaining y in the front. So what will happen in the next step? So this will become 2z is equal to x dou z by dou x plus y dou z by dou y. Finish. This is the required PDE after eliminating the two arbitrary constants a and b. Okay, so let us go to the next question. I do three questions, okay? After that, so form the PDE from z is equal to ax plus by plus a square plus b square. So like the previous question, here also we are going to differentiate with respect to x and with respect to y. So I differentiate with respect to x. So what do you get? Dou z by dou x is equal to, I differentiate with respect to x. So it is a times of 1. And see the remaining terms. Do you see any x, anywhere any x? No x. So what is their derivative? All becomes 0 plus 0 plus 0. So what I get here, I get the value for a. So what is a? Dou z by dou x. Now I differentiate with respect to y. So it is dou z by dou y is equal to, if you see the given function, it has y only in the second place, the remaining place no y. So in the remaining place you get 0, in the place of y you get 1. So what is dou z by dou y? That is equal to just b. Now like the previous question, what do you have to do? You have to take this function and replace the equivalence of a and b. So z is equal to ax plus by, then plus a square plus b square. So z is equal to a. What is a? A is dou z by dou x. So what is a? Dou z by dou x. So dou z by dou x plus, what is b? We have dou z by dou y. So it is dou z by dou y is equal to, what is the a? You know, it is dou z by, here it is plus, dou z by dou x, then whole square plus dou z by dou y whole square. So this is the required PD. Just to check, in the last step you don't find A and B. So the second question is done. It's a very simple one. Let us go to the third one. I think the video will be a little bit lengthy, I feel. So what is the third one? Yeah. So form the PDE from z equal to x square plus a, y square plus b. Answer. So, like the previous question, you have to differentiate with respect to x and differentiate with respect to y and find the equivalence of the arbitrary constants a and b. So it is dou z by dou x is equal to, so differentiate here, both are in multiplication, okay? So you cannot make the other variable as 0, okay? So just differentiate the x part. So what do you get? It is 2x plus 0 and y square plus b. They are in multiplication, don't forget. Okay, so what do you get? So dou z by dou x is equal to 2x y square plus b. So here you can get the value of y square plus b. So what is y square plus b? So 1 by 2x, 1 by 2x dou z by dou x is equal to y square plus b. So this is very important, huh? Because in the place of, because sometimes you cannot remove the arbitrary constant more specifically. Maybe a group can be removed in bulk, okay? So that is what I am going to do. Just I am going to remove the bracket, the entire term, okay, instead of just removing the arbitrary constant. Okay, so with respect to, let us go to the next derivative with respect to y. So dou z by dou y is equal to x square plus a, and the derivative of y square is 2y, the derivative of b is 0. Like the previous step, just to take this 2y to other side. So it is a 2y, 1 by 2y dou z by dou y equal to x square plus a square. Okay, now take the given function. So z is equal to x square plus a, y square plus b. So z is equal to x square plus a. So what is x square plus a? Here it is not a square, huh? Just a. Oh, here also I have written a square. Huh? Okay, just a. So x square plus a. What is x square plus a? It is 1 by 2y dou z by dou y. Multiply. What is y square plus b? It is written here. So what is y square plus b? It is 1 by 2x dou z by dou x. So if you want to simplify further, it is up to you. So what you can do, you can take this 2y other side as well as this 2x other side. So when you take both together, so it is 2x multiplied 2y, that is 4xy. So what you can do, this PDE can be further simplified as dou z by dou y, dou z by dou x is equal to 4xyz. This is the answer. Okay, so that is the part of forming the differential equation by eliminating arbitrary constant. So let us go to the third one. The third one is formation of PDE by eliminating arbitrary functions. Okay, so let us take one question. From there you can understand it directly. So what I try to mean here. So form the PDE by eliminating the arbitrary function z is equal to f of x square plus y square. f of x square plus y square. Okay, here before like the previous one, here also we are going to differentiate with respect to x and y. Say I will write, so answer like the previous steps, we are going to differentiate with respect to x. So what do you get? So it is dou z by dou x is equal to, see, while differentiating the arbitrary function, just in the place of f, what we do, we just put f dash, and after that, don't forget, it is like a chain rule. Okay, so whatever they have written inside the bracket, you have to differentiate partially with respect to x and y. So what I do here, when I differentiate with respect to x, I write f dash. That's all. We cannot write anything else. Just f dash. If you differentiate for the second time, you can write f double dash. That's all. So f dash x square plus y square. After that, don't forget to differentiate the inner part. So here we are differentiating with respect to x. So what is the derivative of x square? It is 2x. Then what is the derivative of y square? It is just 0 because there is no x. So you can simplify further. So it is dou z by dou x is equal to 2x f dash x square plus y square. Okay, so let us go to the next one. So differentiate with respect to y. So dou z by dou y is equal to f dash, same procedure. Okay, f dash plus x square plus y square, f dash x square plus y square. Now you have to differentiate the inner part. The derivative of x square is 0, the derivative of y square is 2y. So what do you get now? So it is dou z by dou y is equal to 2y f dash of x square plus y square. Here our task is to find the PDE by eliminating the arbitrary function. It means in the answer you should not see any f. That is the meaning. So what I am going to do, I am going to divide this 1 and 2. Okay, so see here, 1 divided by 2, which implies you have to divide both sides. Dou z by dou x divided by dou z by dou y equal to 2x f dash of x square plus y square by 2y f dash of x square plus y square. So don't forget, this value, the value of this derivative is written here, the value of this derivative is written here. That's all. Okay. So now you can cancel what? You cancel f dash in both places. So what is left? What is left is dou z by dou x by dou z by dou y equal to, even you can cancel these two. Okay, so what is left? It is just x by y, x by y. So after that, what you can do, just you can cross multiply. If you cross multiply, what you get? It is y dou z by dou x equal to x dou z by dou y. So now take to other side. So y dou z by dou x minus x dou z by dou y is equal to 0. Finish. This is the answer. This is the required PD after eliminating the arbitrary function. Okay, so let us go to the second question in the same idea. So form PD from z is equal to, let me take the question, x plus y f of x square minus y square. So answer. So differentiate with respect to x. So dou z by dou x is equal to, don't forget, in this place you have to be very careful. Here two things are multiplied. Don't forget to apply the product rule. Okay, uv dash plus vu dash. So that formula you have to use, huh? So I write the formula in the denominator down so that you can see. So it is u v dash plus v u dash. So so what is x plus y? And the derivative of v, that is f dash, you know how we did in the previous place. So the derivative of f is f dash, and don't forget to differentiate the inside. So it is 2x minus 0, then plus v, that is f of x square plus minus y square, the derivative of u. So you have to differentiate with respect to x. So it is 1 plus 0. 1 plus 0, because here when you differentiate x it is 1, when you differentiate y with respect to x, that is 0. So simplify. So dou z by dou x equal to, you can bring this 2x to the front, huh? So it is 2x x plus y f dash of x square minus y square, then plus f of x square minus y square. Finish. Now I am going to differentiate with respect to y. In the same procedure, okay, you have to apply the product rule. So dou z by dou y, okay, so it is u v dash plus v u dash, but this time we do with respect to y, yeah? So it is x plus y, the derivative of f is f dash, the derivative of x square minus y square is 0, the derivative of x square is 0 minus the derivative of y square is 2y, then plus the derivative of just write the v, that is f of x square minus y square, the derivative of u. What is the derivative of u with respect to y? In the first place we have x, so with respect to y it becomes 0. In the second place we have y, with respect to y is 1. So simplify this. So you have to bring this minus 2y front. So what you get now is dou z by dou y equal to minus 2y x plus y f dash of x square minus y square, then plus f of x square minus y square. Okay, now what I do, because there are something to be, we have to eliminate the arbitrary function. So the best way I write it directly without further delay. So what I do, I take this equation and I am going to multiply y on both sides. So what I do, I multiply y on both sides. So what will happen? So it is y dou z by dou x is equal to 2xy. See here I put y, yeah? Then x plus y. The remaining I write as it is. F dash of x square minus y square. In the second term also y f of x square minus y square. Okay, so after that, I take this equation, and I multiply by x, multiply x on both sides. So what do you get? It is x dou z by dou y equal to minus 2x. Here I put that x, okay? X plus y f dash of x square minus y square, then plus x f of x square minus y square. Now you understand why we multiply x and y in those two partial derivatives, just to see these terms, just to see this and this. They are one and the same, but with a different sign. Here it is plus, here it is minus. Okay, so what I'm going to do, I'm adding these two equations. Okay, just I add these two equations. Okay, so when I add, what do you get? What do you get? Here I just add, okay? I add these two. So what do you get? Y dou z by dou x plus x dou z by dou y. Here I add these two. When I add these two, you will get 0 because both are same with a different sign. Then plus, when I add this, you get y f of x square minus y square plus x f of x square minus y square. Okay, so this 0, just ignore it. So what do you have now? Y dou z by dou x, then plus x dou z by dou y equal to, see here, in these two terms, we have x and y, and in both places we have f of x square minus y square. So what you can do, you can write as y plus x f of x square minus y square. Just to see this, we reach a place where you can replace the entire right hand side by the given function. Just to see here what is given in the question and what we reached here on the right hand side are one and the same. So in the place of this entire term, you can just put z, that is z. So y dou z by dou x plus x dou z by dou y is equal to what is on this side. Don't forget, it is given in the question, that is z, that is z. Finish. This is the required PDE after eliminating the arbitrary function. Okay, now we enter the last topic, the classification of second order PDE. The classification of second order PDE. A linear, just I write something, a linear second order PDE in two variables has the general form A dou square z by dou x square plus B dou square z by dou x dou y plus C dou square z by dou y square plus D dou z by dou x plus E dou z by dou y, then plus fz equal to 0. Here we define the quantity, we define a quantity b square minus 4ac is called as the discriminant. Okay, so based on the value of the discriminant, we have three cases. If b square minus 4ac is less than 0, then we say the given PDE is elliptic. The second case, if b square minus 4ac equal to 0, then we say the given PDE is parabolic. The third one, if b square minus 4ac is bigger than 0, then that is positive, then the PDE is hyperbolic. Okay, and I put a note here. The first note is here we consider the cases where A, B, and C are just constants, or you can say numbers, because there are some questions with variables. There, the nature of the PDE will be different in different region. So here, the second note is all first order PDEs are parabolic. Don't forget. When they give the first order PDE and they ask what is the nature, what is the classification, you have to say it is parabolic. Okay, so let us go to the question directly, and these questions are very simple in nature. Just see here, I just take some questions from the book. Question 1, classify 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 the PDE. So 2, dou square z by dou x square it is minus 3 dou square z by dou x dou y plus 7 dou square z by dou y square equal to sine 3x plus 4y. So it's a very simple question. So what you have to do, just to compare. Okay, so compare with this term. A dou square z by dou x square plus b dou square z by dou x dou y. Then plus c dou square z by dou y square. Okay, you have to just compare. Compare the coefficients of these given partial derivatives. Just to see here, in the place of a, what we have. Don't forget, a is the coefficient of dou square z by dou x square. Don't forget, x square. Before the x square, you have to take the a. So what is the a? Here, you can say here, a is equal to 2. And what is b? What is b? b equal to minus 3. And what is c? c is equal to 7. Okay. So what you have to do? You have to find the value of discriminant. Discriminant b square minus 4ac. So what is b square? Minus 3 whole square minus 4 times of a, that is 2, and c, that is 7. So what do you get now? This is equal to 9, 8 minus 8 multiplies 7, that is 56. So you have to check whether it is negative, positive, or 0. Here it is negative. We don't want the value. Just you have to say whether it is negative or not. So here it is negative. If it is negative, what is the case? If it is negative, it is elliptic. Don't forget. So it's elliptic. So you can say the given PDE is elliptic. Finish. Very simple. And see here in the right hand side, they have given some function. No need to care about. Okay, when they ask you to classify, don't forget this is not at all important. This is not important. The classification is based on the coefficients of the second order partial derivatives. Don't forget the coefficients of the second order partial derivatives. Don't forget. Okay. So let us go to the second question. So question number 2. Classify. I do one more question. Classify 3 dou square z by dou y square plus 4 dou square z by dou x dou y equal to e power x plus 7y. So what you have to do? You have to compare with this. So a dou square z by dou x square plus b dou square z by dou x dou y, then plus c dou square z by dou y square. Don't forget, as I told before, Here you have to find the value of a from x square, but here they have given y square. Don't forget. Don't say directly a equal to 3. A is not given here in this question. They have given this derivative here. This derivative here. The second order derivative with respect to y is given here. So what is a in this question? Here a is not given. Don't forget a is not given. So a is equal to 0. B is equal to 4 and C is equal to 3. So the discriminant B square minus 4AC equal to 4 square minus 4 times of 0 times of 3, that is equal to 16, which is bigger than 0. If it is bigger than 0, don't forget. If it is bigger than 0, what is given here? If it is bigger than 0, it is hyperbolic. So you can say the given PDE is hyperbolic. Question number 3, maybe the last question. Question number 3. Classify 12 dou z by dou x plus 13 dou z by dou y plus 14z equal to ln xy. Okay, so don't forget. Here, do you see any second order? Do you see any second order derivative? This is first order. This is first order. This is first order derivative. First order derivative. Do you see any second order? So no second order in this. No second order derivative. No second order derivative. And if there is no second order derivatives, then because these values are picked, the values of A, B, C are picked from the second order derivatives. Don't forget. The values of second order derivatives are picked from A and B. A, B, C are picked from second order derivative. But here there is no second order. So what is the value of A, B, C? Here A is equal to 0, B is equal to 0, C is equal to 0. That makes the discriminant as 0. The discriminant B square minus 4AC. So everything will become 0. So this will become 0, which implies the given PDE is parabolic as per the definition. Okay, so see here, if it is 0, then it is called parabolic. Okay, so that's all for today video. So thank you very much.